Hi, good day. Let us discuss about the reflection of light. What can you see when you look at a mirror, or a polished metal, or a still pool of water? You can see your image. Why? These objects are image-reflecting objects. There are two types of images formed by reflecting surfaces. They are real and virtual images. Real image is always inverted and is formed by actual rays of light. It can be projected on the screen. Virtual image is always erect and is formed by apparent rays of light. It cannot be projected on the screen. When light hits a smooth surface, like a mirror, light is reflected. Reflection is the turning back of light when it hits a barrier. The angle between the incident ray and the normal rays is called the angle of incidence. The angle between the reflected ray and the normal ray is the angle of reflection. The law of reflection states that the incident ray, the reflected ray, and the normal to the reflecting surface all lie in the same plane. The angle of incidence is equal to the angle of reflection. The figure shows a girl combing her hair with her left hand. However, in her image, you will notice that she is combing her hair with her right hand. This effect is known as the mirror left-right reversal. The left side of the object appears as the right side of the image, and the right side appears as the left. This also explains why the word ambulance in an ambulance car is flipped. The mirrors that we use as looking glasses are plane mirrors. The image formed by a plane mirror is always erect, virtual, laterally reversed, same size as the object, and found to be apparently behind the mirror. Reflection not only happens on a smooth surface like plane mirrors, but also happens on rough surfaces. This is why reflection is classified into two types. When parallel light rays strikes these materials, light rays are reflected in a regular pattern. This is called regular reflection. When parallel light rays strikes unpolished surfaces, the reflected light rays scatter in all directions. This is called diffused reflection. The law of reflection still holds for each ray of light. Diffuse reflection plays an important role in driving at night. It helps us see the road surface illuminated by our headlights on a dry night. But when the road is wet, there are still diffuse reflection and traveling on the road is more difficult. Look at your reflection on a shiny metal spoon. Is your reflection the same on the two surfaces of the spoon? How will you compare your reflection on the surfaces of the spoon? This is a reflection on curved mirrors. A curved mirror is a reflecting surface in which each surface is a section of a sphere. There are two kinds of spherical mirrors, the concave and convex mirrors. If the reflecting surface is curved inward, it is a concave mirror. If the reflecting surface is curved outward, it is a convex mirror. There are mirrors terminology which you should know. They are the following. Vertex or V is the middle portion of the mirror. Center of curvature C is the center of the sphere of which the curved mirror is a part. Radius of curvature or R is the distance of the center of curvature from the vertex. Principal axis P is the line drawn passing through the vertex and the center of curvature. Secondary axis or S is the line drawn through the center of curvature to any part in the mirror. Aperture A is the opening of the mirror. Focus F is the point where the reflected rays meet. Focal length or F is the distance between the focus and the vertex. How can we construct, locate, and describe the image formed by spherical mirrors? To construct the image formed by spherical mirrors by the ray method, draw at least two of the following rays from point A on the object. Ray 1 is an incident ray parallel to the principal axis and is reflected through the principal focus. Ray 2 is a ray traveling along a secondary axis and passes to the center of curvature, which is reflected back along itself. Ray 3 is a ray that passes to the focus and is reflected parallel to the principal axis. This figure summarizes the kind of image formed in a concave mirror at different position of the object. Study how the image is constructed using the ray method, and note the kind of image formed. In a convex mirror, the image is always smaller than the object, erect and located behind the mirror. As the object is brought closer to the mirror, the size of the image increases, but can never become as large as the object itself. If this is your first time watching my video, make sure you hit the subscriber button. Thank you for watching.